All right, so this was the first Warp Core that I was building. This one's metal. Um, so metal, of course, acts differently in microwaves than this glass. These, let's try to focus on that. Well, these are also the same shape as these. They're spheres, and the spheres are really close together, and they're actually glued together. And the reason why that won't matter is because there's no seal in between these. None of these spheres are completely circular, so there's always like so there's a little gap in between all of them. So yeah, the interior is round, and then the exterior of them looks like the front of this. And then I also have these metal shafts that are glued to the spheres, and these metal shafts give me something to stick something to that will allow me to insert this into the main cylinder. Let's see. So I'll go ahead and put this here. Those are the two warp cores. Oh, dang. Yeah, no, seriously, look at that. That is so small in comparison to this one. And the reason why is because this type is working differently than this. Like with this, the microwave hits these and then bounces away. So it's reflecting like a mirror. But this, the microwaves will go right through the glass, not affected by anything. So there is no reason why I need to gap these out, because the microwaves are going to go through them and bounce off the metal walls inside the cylinder. All right. So here's the cylinder. I'll kind of go ahead and show how this one actually fits in there. And there is no specifications. Like what I think happens, or what I believe that will, what I theoretically believe will happen, is because this is like a cup shape or whatever, it basically squeezes space inside. So you could think of like pressure, the little arrows pointing off the walls and the direction of the walls. So you would actually have like they'd all be pointing inward, all the little arrows. And then for the pressure points on the dome part, is the arrows be pointing outward. So that's the direction of space to move. So this installs in here, and it doesn't matter how you install it. It doesn't matter how you put the magnetron on. It's just space will be shaped in formation of these. So depending on which direction you put this, that's the direction of force. So that's that. Let's go ahead and see inside the cylinder. That's that. Maybe I should take off the ring here. So, well, not the ring, but the cap. And that's why I bought that, because they're really easy to take apart. It's really fast. So that's these spring things allow or make the warp cores to sit in the center. It centers these. So that's that in the center, the glass warp core, and the metal warp core, a little bit different, where the metal plate sits up against the wall, and these just clip into place. And these, both of these are designed so they go in really quickly. Everything is made to snap together, so I can test stuff more quickly that way. So again, what I want to happen is the microwaves interact with these dome shapes. Now they're virtual particles, and the virtual particles are somewhere close to the walls. And because there's a wave moving past the virtual particles, it will cause the virtual particles to interact with this and then suddenly disappear. And what happens is in theory, a virtual particle is like a tornado, where they squish up space and then they expand and become the space again. So they crunch up space and then let it go. And when they clench up space, that's when they seem to act like a particle, when they interact with time, and that makes them a particle. And so if a particle hits this wall and bounces off, then the waves will go outward and space will go in the direction of the virtual particle. So there will be space expanding out this way. Then space on the inside will be contracting. So a device like this, in theory, would want to move like that, in that direction. And then the same thing with this, but you could imagine the wave is going straight through that warp core, and then it's going straight back through the warp core. Now, the microwaves, like light going this way and light going this way, it's not going to interfere with each other. The waves are not going to interfere with each other, but the virtual particles interact with the waves. And so virtual particles, like in a sound wave, particles in a sound wave, if the waves get to a certain point, then it won't even interact with the virtual particles because there will be a cancellation. So don't want a cancellation. You want the wave moving this way and moving this way with no cancellation. So in this one, you can imagine the waves moving through it, and it's just like bang, 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 hitting all these walls. But in this one, it actually has to hit the surface and then bounce away, hit the surface, bounce away, hit the surface, bounce away. So I think that if this actually would work, then I believe that the glass would actually be more powerful, because it's actually just slamming them through the walls and then slamming them back through the walls. So I believe that an actual working model would actually be something more like glass, even though the first thing that I made was this. I did believe like crystalline or glass would work the best. So I gotta test them all. So again, the vacuum can vacuum out through all of these little pieces of glass. There is a tiny little gap there that's just wide enough that a particle could fit through, nothing more. So I did get another main piece. This is a rotary vane vacuum pump for like HVAC or whatnot, and there are two. So this is the most powerful type of vacuum pump, and that's the type of vacuum pump that I'm going to be using for the test. And the idea is that by removing all of the air, then that will cause entropy. And my idea of entropy is you take an object and the object is moving, and by squishing it or by removing its mass, reducing its mass, then it actually causes it to be more energetic, like a ball bouncing back and forth between my hands. In order for it to stay at the same speed, when I push my hands together, it's going to bounce back and forth more quickly. That's it.